Hello everybody, I will start my today another coding practice. So today I will solve this question. So binary tree maximum path sum. Okay. And so in this question, a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connection them. So path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. Okay. A node can only appear in the sequence at most once. Yep. Note that the path doesn't need to pass through the root. Okay. The path sum of a binary tree is the sum of the nodes values in the path. The path sum of a path is the sum of the nodes values in the path. Okay. Given the root of a binary tree, returns the maximum path sum of any non-empty path. I see. Okay. So, yep, in this question, I'm giving a binary tree. Then I will think of every possible path which is not empty. Then I will think of the sum of the nodes in each path. Then my task is to find the maximum one and return it. Okay. So I will quickly clarify the question. So the input of this question is obviously the root, and because the number of nodes is from 1, so this root cannot be none. No. Number of nodes, yeah. Okay. And node value is, minimum negative 1000 and maximum 1000. So this means that, I think this is important thing, because think of the case when all the nodes in the binary tree is negative. I mean, all of them are negative values. In that case, even in that case, I have to find the path which is non-empty. So if I can choose the empty path, the maximum would be 0 in that case, but it's not possible. So I will, obviously it should be the maximum node value. Yeah, in that case. Like -1 or something. Okay, so I've clarified the question statement. So let me think how I can solve this question. So for example, in this case, I'm pretty sure that the maximum path sum is 4 plus 3 plus 5, which is 12. If I choose, say, 5, 3, and then go above and go to 2, it should be 2 plus 1 plus 3 plus 5, which is 11, which is smaller than 12. So I should choose 4, 3, 5, which is whose sum is 12. Yep. So I think that the brute force approach for this question is obviously think of every possible path and then I guess the maximum of them. So yeah, but the problem is how I should think of every possible path. So I think I can think of it in this way. So if I choose node 1, then I will basically I think I can use the recursion. Yep. So I will think of each case. Okay. Okay. So I will divide this question into this. I will think that the path goes through the node, some node, obviously. And I will think of the node. And I will think of the node which is the highest position in that path. And I would say first I will think of this. So what's maximum pass sum? That's the path goes through this node 1. I will think of this question first, and then I will think what's the maximum path sum which goes through node 2. Then also I will think what is the maximum path sum which goes through node 3 as the highest node. So it means that it doesn't go up. Yeah, I will think of that. Yeah, so I will divide it in that way, and this works because obviously highest node in path is only one. Yeah, there cannot be two or more highest node in the path because this is the binary tree. Okay, so that's something what I will think first. I will think each of them. And I will get the maximum of them, and that's the answer. Yeah, so that I will think. And for that, what I need to get is, so if I choose this node, what is the maximum value which comes from the left subtree? So I will think that the path, which goes from node 5 and goes to left node and right node, which never goes back to 3. And also, obviously, it goes only one direction of, let me think with this. So in this case, what I want is, what's the maximum path sum which comes from node 5 and which comes from node 5 to 3. So obviously it cannot be 6, 5, 7, because if I choose that, it doesn't go to node 3. And also it is covered in the highest node 5 case. So in this case, I will think, 5 plus 7, 12, or 5 plus 6, 11. So once I get that sum, so so firstly I get some tail y, and also, so I should say it like this: max sum below y plus max sum below z plus x value. So obviously this is the maximum path sum with height node x. Yep. And one more thing I have to take care is that max sum below y can be negative. Like if all the nodes, under node y is negative, including node y, the max sum below should be negative. In that case, I can just choose that I don't choose max sum below. It's totally fine because I just have to finish the, path with node 5. Like this in this case. And when I think of this node 3, the maximum path sum from right subtree is minus 1 plus minus 2. Negative 1 plus negative 2 is negative 3. in that case, I don't choose it. And the maximum pass sum should be 4, 3. Yeah. Or if this is like negative 4, even in this case, I don't choose any of left pass or right pass. So in this case, only node 3 is, maximum, pass sum. Yeah, so it should be 3. Okay, so I can say this should be like this. Okay. So I think I can work on the implementation. So basically, I can use the recursion, and this recursive function does two things. First, recursive function is called per node, and for each node in the recursive function, I will do things. Firstly, I will calculate the max pass sum with height node. Then I update the global maximum with that value. Also, because I will return the maximum sum below that node. Yeah, because that can be used in the caller of the recursive function. Yep, that's it. And the time complexity should be O of n because I visit each node once. And inside the recursive function, the operation is taken with the constant time because I can know I call the recursive function from that function, and immediately after getting the result from the node below, all I have to do is just the kind of calculation. Okay, and for space complexity, I'm pretty sure this is O of n because the only data structure which takes more than the constant is the recursion stack. And in the case when the tree is practically linked list, in that case, the height of the tree should be exactly number of nodes. So in that case, the recursion stack should be number n. Yeah, length n. So it should be O of n in the worst case. Okay, so that being said, I will start the implementation. Good. I will quickly write something. So this is the recursive function I will call, I will define, and basically this does two things. The first thing is update global max pass sum. And those I will return node max sum from this node to leave. Yep, this is it. Okay, that being said, I will start the implementation. Okay, so I implemented aside from the recursive function. So what I will do is in line 47, I initiate the max pass sum with rooted value. I must not initiate this with 0 because of the reason I told you before. So in the case when all the node values are negative, the max sum pass sum is not 0. So instead of that, I initiated with rooted value. Okay, and in line 48, I call the recursive function with the root node, and then inside of this recursive function, max pass sum is updated. So in the end, I return the updated max pass sum. Okay, now I implement the recursive function, update max pass sum. Okay, so firstly, I will call the before that, let me think of the edge case. I mean, base case. If node is known, I don't update the maximum path sum, and I just return 0. Yep. Then I will think of the case when current node is not known. In that case, I call the node.left and node.right recursively. And I get this. Left max sum turn leaf. Okay. And also from right, I get something like this. Yeah. And as I said, this is current path sum. Oh, or I should say max sum. Let me name it root. Oh. Okay, so here max pass sum through root. So this is, I can think that the local maximum. Like this. Then I will update the global maximum with this local maximum. Okay, now max pass sum is updated. And the last task I will do is return the max sum from this node to any leaf. So this should be something like this. Yep, this is quite simple because I mean the maximum sum from this node to any leaf should be either of, I mean, at least I start from root bar, this is decided, and I go to left or right child. And if I go to left child, the maximum sum from left node till leaf is, something returned by the recursive function in line 50. So I use that result. And same way for right. In the case I choose the right child, I can make use of the result from the recursive function I code in line 51. Okay, so this is it. Let me walk through my code with an example. I will choose a very simple case like this. No, this is not so interesting. Yeah, okay. Let me go with this. Yeah. My goal is to cover all the lines, not like completely covering all the cases. So let me, walk through this simple example. So in this case, in line 65, max pass sum is initiated with 1. Oh, by the way, the expected answer is 6. Obviously, 2 plus 1 plus 3. Yeah. Okay, so now in line 67, max pass sum is initiated with 1, and I call the recursive function in line 68 with root node. So now currently root node is 1. Yep, and because root is not known, I go to line 55, and I call the self.update max path with root.left and root.right. Okay, so let me write something here. So firstly, I call this. Then in line 55, I call root.left, which is 2. And also in line 60, I go root.right, which is 3. Yep. So I'd like to know what this returns. Yeah. So in line 55, I call root.left, which is node 2. So I go to line 55. Yep. And everything, what returns here. So in root 2, root is not known. So I go to line 60 and I go left max sum tail leaf, and also I will think of right max sum tail leaf. So again, I call the recursive function, but in this case, this should be none because node 2 doesn't have any child. Yep. And when I call this with none, in line 58, this returns 0. And I don't update the max pass sum. Yep. I come back and into line 63, I will think of the case when root is node 2. In this case, in line 63, root of the value is 2 and red max sum tail leaf is 0 and right is also 0. So this should be 2 plus 0 plus 0 is 2. Okay, then in line 66, update max pass sum with 2. So this is now 2 in line 73. Yep, I wrote it down. And in line 68, I write the maximum of root of the value, which is 2 plus 0 or 2 plus 0. So I return 2. Yep. Okay, so now 2 is returned. And for node 3, I'm pretty sure the same thing happens. And this returns 3. So in root node 1, 2 and 3 is returned. No, sorry, 2 and 3 is returned. Okay, so in line 63, in the case of root is node 1, max pass sum through root is root dot value 1 plus 2 plus 3. Which is 6. So now in line 66, max sum is updated with 6. Yep. And in line 68, I've written something, but it doesn't matter. Yeah. But just in case, this returns 1 plus 2 or 1 plus 3. The maximum one is 1 plus 3 is 4. So 4 is returned, actually. Okay, so this is it. And I finished the recursion. So in line 75, I already marked sum, which is 6. Okay, sounds good. So I covered all the lines in this implementation. I'm pretty confident on my code, so I submit it. Sorry, I don't need cell here. Update max pass sum. Okay. Good, accepted. I submit my code. Oh, wrong answer. Hmm. Expected 16, but output 15. Okay. Hmm. Okay, so I will take a look. Wait, how is the tree look like? Hmm. So probably it should look like 9, then 6, -3, null, null, -6, 2, and null, null. Oh, no. What do you mean? So, -6, 2, then null, null, 2, null. Wait, how does it look like? Is it look like this? Hmm. Two, null, null, 2, null. Or is it like, do I have to put null here or not? Probably no. Null, null, I see null, null, 2, null. Then -6, -6. Oh, is it look like this? Maybe. I have no idea. Let me think. Ah, I see. Now I find the reason. So here in line 75, I have one more choice. Or I should say, if left max sum tail leaf is negative, I don't have to take it. So just like I did in line 70, I do something like this. Yeah, so in this way, let's think as like this. Yeah, in this case, left max sum till leaf is -2. And yeah. Oh, so I mean, actually, the naming is wrong. This doesn't have to be until leaf. Yeah, this is just what I want is something like the path which starts from the root node, or I should say some node, then goes down and never, yeah, goes down just goes down. So let me rename this to left max sum going down. Yeah. So when I think of that, when I think of the, max sum going down from node 5, yeah, maybe I will go to 5 then the -3 or 5 then -2. But obviously that makes the body smaller. I just can finish with node 5. Yep. Okay, let me use my code again. With the test case I missed. Good. I submit again. Okay, good. So I will quickly wrap up on this coding practice. Yep. So in this video, I solved the question binary tree maximum pass sum. And in this question, I'm giving a binary tree, and my task is to find the pass sum whose maximum is non-empty path sum. Okay, sorry. I will think of each non-empty path, and for each, I think of the path sum, which is the sum of the node values on the path, and then I will return the maximum path sum. Yeah, so that's a question. And for this question, I use the recursion. So I thought for each node, what's the maximum path sum which goes through that node? And thus, then I calculate the local maximum, and then I return the global maximum of these local maximums. Yeah. And to calculate that, in the recursive function, I return the maximum sum from the root node till, yeah, and going down. Yeah. Okay. And obviously the pitfall of this question is that even though the maximum path sum is returned from the left child or right child, I have a choice that I just don't choose it. Yeah. And the same way, I get the, max sum going down from left node and right node. And and I can use it, either of them, or I have another option that I don't use it and just use the root node only. Yeah. So I could notice that in line 74. Yeah. But I overlooked it in line 80 and 81. Yeah. So I was almost there. Yeah. Okay. That being said, I finished my today's coding practice. Thank you so much. Bye.